Okay. So today we're going to talk about functions, which is section 2.1. We're going to talk about functions, and also we're going to cover section 2.2, only piecewise functions. So first, what is function? So the function, you have the definition here. It's a correspondence between two sets of elements. So it's a correspondence between two sets of elements such that to each element in the first set, they correspond one and only one element in the second set. The first set is called domain, and the second set is called range. Okay, so this is the picture. So we have set of element, which is called domain. And set of element pretty much can be anything. Can be names, numbers, whatever you want to define to be set of elements. For example, let's say all of you, all of this class is making, this is my set of my Monday, Wednesday class, okay? So all of you guys, so here I have list of names. So we have student A, student B. All my students in this class, I can say this is my domain, this is set of elements. Then we need to have correspondence between these now students and something else. So let's say I'm going to do something with each of you. I'm going to grade your, let's say, test 1. And I'm going to grade each of your tests, and I'm going to get another set of elements, which is called the range. And this set of elements is going to represent your grades, right? So let's say somebody get 100 in test 1, somebody gets 85, and so on, right? So this correspondence between students in my class and grades in test 2, it's called a function. And this is the notation of function. So what you're doing with each element from the domain to get the elements in the range is called function, and usually using f of x is the notation of function. This is functional notation. And then also it's very important that for one student, there is only one grade, because that's what it says here, right? Only one. It says one and only one element, which means for one student, there is only one grade in test 1, okay? Each student get only one grade, okay? That's very important. Now, we're talking about the notation of function. The first letter f, usually using f of x, if you look at the examples down here, f of x, f of something. So f of x means you have a function. F, look at f like the name of the function. Of x means you have a function. You don't do anything with f and x. You don't multiply, you don't do anything. This here, f of x, tells you you have a function, and the name of the function is f. And the elements in the domain are x, okay? So usually domain is represented with x, and the range is represented with y, okay? So if you see f of x is the same like y. So when you graph it, when you talk about graph of function, f of x is notation, it's a functional notation of y, okay? It's the same like the range, okay? So now, let's see what we have. We have functions specified by equations. So there are different ways to represent the function. We're going to talk about equation of the function. And the equation have two variables, and I told you x and y. The input is x. The input, or the independent variable also is called, it's x. And the output, which is the dependent, is called y. Usually we're representing the equation with y, okay? And then let's go ahead and look some examples of equations. So here we have the function, it's f of x given. And the equation of the function is after the equal sign. Yes, question?
Isn't he gonna come back and say if it's working?
Are you guys okay? Or somebody just unmuted yourself accidentally? What's happened?
I'm sorry.
Okay. Okay. Thank you. Okay. So here we have equation of the function f of x means we have the function f of x, and then the equation of the function is, this is the, after equals is give you the function, give you the equation, 4x minus 5. So that means this function is multiplying 4 times x, each of the elements, and subtracting 5. So this is what this function is doing. Multiplying each x by 4 and subtracting 5. So now what you need to do, we need to do f of 1. What that means? That means in the place of x, I'm going to plug it in 1. Okay? So that's all what you're doing. You're going to follow the equation, which is 4x minus 5. And in the place of x, you're going to plug it in 1. So just going to copy that, 4x minus 5. You're going to copy the function the way it is, and whatever you see x, you're going to put parentheses. And then inside the parentheses, you're going to put whatever number they give you. In this case, they give me x is 1. So I'm going to plug it in 1 for x. And then you're going to simplify. 4 times 1 is 4. And then 4 minus 5 is negative 1. So the answer is negative 1. Everybody understand that? Let's do it again. Yes? Okay. Let's do it one more time. The next one is the same. F of negative 3. So that means in the place of x, you're going to plug it in negative 3 now. So you copy your function, which is 4x minus 5, and you're going to plug it in what? Negative 3. In the place of x, you're going to plug it in negative 3. So what you're going to get? We're going to get 4 times negative
17.
Yes, 4, I'm sorry. 4 times negative 3 is negative 12. Minus 5 is exactly negative 17. Good job. So the answer is negative 17. Okay? Then let's do the next one. F of x minus 1. So we're going to plug it in x minus 1 now. So we're going to do the same. Copy the function and put parentheses for x. Oops, sorry, I clicked something. Where was that? Okay, here. So we have 4, gonna plug my x minus 5. And what is my x? X minus 1, whatever it says. And then here we're just gonna simplify, we're gonna multiply 4 times x is 4x. 4 times negative 1 is negative 4. And minus 5. We're gonna just combine those two like terms. And my final answer is 4x minus 9. So that's your final answer, okay? And then we have another one. We're gonna plug it in what? X is gonna be 1/4. So let's do the same. Follow the function 4x minus 5. And then in the place of x, what you're gonna put in? 1/4. So 4 times 1/4, this cancel out, so it's gonna be 1 minus 5 is negative 4. So my answer is negative 4. Okay, everybody so far so good with functions?
Yes.
Yes, ma'am.
Okay, so then we have another one where it's algebra functions. So here we're going to have two functions. We're going to have function f, we're going to have function g. And what you're going to do, we're going to do different things with them. We're going to add, subtract, multiply, divide functions. We're going to keep it with x. You're going to plug letters. You're going to plug numbers, whatever it says. We're going to do whatever it says. We're going to do different combination of functions. So this is what you have. For number 2 to 10, here it says we're going to use, this is my function f. X squared plus 1 is f. And g, another function, it's x minus 4. So these are the two functions. You have two functions given. Now, if I have, for number 2, I have to do f plus g and replace x with 5. For number 3, I have to do f minus g and replace x with 2c. For number 4, I have to multiply, right, f times g and replace it with x with negative 2. Number 5, it's dividing f divided by g and replace the x with 0. So this is how you do it. If you plug it in a number for x, so if you have, see if this is number only, here and here for these 3, the easiest way, the fastest way to do it is if you plug that number for x for both of the functions. So I'm going to do f of 5, and then I'm going to do g of 5. And then I'm going to get 2 numbers, and then I'm going to do whatever it says here. I'm going to add the 2 numbers I get, okay? So that's easy to do it. Or you can just expand it and plug it in, but still it's easy if you just do this step by step. So I'm going to replace, follow f. F is x squared plus 1. And then I'm going to follow g, which is x minus 4. And I'm going to plug it in for both of the functions. I'm going to replace x with 5. And then I'm going to simplify. 5 squared is 25 plus 1 is 26. And 5 minus 4 is 1. So these are the 2 numbers I get. Now, what I'm doing with those 2 numbers, I'm going to do exactly what it says. It says f plus g. So I'm going to get the number from f, 26, plus I'm going to get the number from g, which is 1, and I'm going to add those numbers. So my final answer is 27. Okay? Everybody good so far?
Yes, ma'am.
Okay, I'm gonna skip number 3. I'll be back when it's plugged in something later or x or something. I'm gonna go back to this. It's a little different. So let's do number 4, f times g of negative 2. So again, I'm gonna do f of negative 2. And then I'm gonna do g of negative 2. And I'm gonna get 2 numbers, and then I'm gonna multiply those 2 numbers, right? Because it says f times g. So what is f of negative 2? I'm gonna have f is x squared plus 1, and g is x minus 4. And then you're going to plug it in. We're going to plug it in negative 2 for x now. Negative 2 and negative 2. So what we have, negative 2 squared, always when you plug it in, make sure you put parentheses, is very important. So negative 2 times negative 2 is 4, plus 1 is 5. Negative 2 and minus 4 is negative 6. So what I'm going to do with those 2 numbers, I'm going to multiply f times g. That's what it says, f times g. So I have to do 5 times negative 6. What is 5 times negative 6? Negative 30. Okay? So that's how you do those. Now, number 5 is the same idea. We have to do f of 0 and g of 0, and then divide those numbers. So what is f of 0? Let's do that. F of 0 and g of 0. So f of 0 was x squared plus 1, that's f. And g of 0 is x minus 4, right? And I'm going to plug it in 0 for both of those x's. So 0 squared is 0 plus 1 is 1. And 0 minus 4 is negative 4. Now what I need to do with those 2 numbers, I'm going to divide them. So it's going to be f is in the top over negative 4 divided by g. So that will give me negative 1 over 4. So just leave it like a fraction like this. Okay?
Yes, ma'am.
So that's all what you're doing. Now, here we have also plugged in numbers for this. So let me go ahead and show you how to do number 3, where you have to plug it in 2c. So for this one, because it's f minus g of 2c, which is, I'm going to show a little different ways for this one, because it's not just a number, it's number with letter 2c. So what you do here, you're going to copy. It's easier if you do 2c, plug it in F, minus plug it in G. So I'm going to put it together because my answer is not going to be just a number. My answer is going to have c. So it's going to be expression. So that's why you're just going to follow F. So I'm going to put F in parentheses, minus G in parentheses, and then I'm going to plug it in 2c for x. So this is F, minus this is going to be G. Okay, so what is F? F is x squared minus 1, so it's going to be x squared minus 1. And then in the place of x, sorry, I need a little more room here. In the place of x, I'm going to put 2c, and then the other function was x minus 4. And then I'm going to plug it in, what I'm plugging in? 2c. That's my x. X is going to be replaced with 2c. Okay, and then I'm going to simplify this. I'm going to simplify it. So I'm going to follow the parentheses and all that. So first I'm going to do 2c squared. So I'm going to square both of those. So it will be 4c squared minus 1. And then I'm going to distribute the negative 1 here. It's a negative 1. So it's going to be negative 2c. And negative times negative, it's plus 4. And then after that, you're going to combine like terms. So the only like terms are 1 and negative 1 and 4. So my final answer should be 4c squared minus 2c plus 3. See, the answer is expression with c. So this is a little different. Now, if it's not f minus g, if it's f plus g, it's going to be plus in the middle. If it's f times g, it's going to be times multiplying in the middle. If it's dividing f over, you're just going to copy f over copy g and just replace x with whatever is given. Okay? So that's how you do those where you have letter in the place of x. Okay? So let's continue from there. We did number 5 and 6 is the next one. Okay, 6 is another like a combination with functions. It's algebraic expression pretty much. So what you're going to do, we're going to do this first. G of negative 3. So I'm going to evaluate G of negative 3. And then whatever I get for G of negative 3, I'm going to multiply it by 4. So what is G of negative 3? G of negative 3, I'm going to follow the function g, which was x minus 4. I'm going to replace x with negative 3. And that will give me what? Negative 7. And then this negative 7 is going to replace g of negative 3. So I'm going to get 4 times negative 7, which is negative 28. Okay? So my final answer is negative 28. Okay? So let's go to the next one. Next one, we have two things to evaluate, f of 4 and g of negative 1. That's what you're going to do first. And then I'm going to have 3 times whatever I get minus 2 times whatever I get, right? And then I'm going to simplify this algebraic expression. So first, what is f of 4? So let's get f of 4 first. So f of 4, and also I need to get g of negative 1. So what is that? We're using the same functions for all the way to 10, correct? Yes. Okay, so what is f? F was x squared plus 1. So it's going to be x squared plus 1, and the other one was x minus 4, the same function. So what you plug it in, we'll plug it in 4 for f and -1 for g. So here, just be careful which function you're using. Do you use for f or using g? So be careful you plug it in the right function. So let's simplify. 4 times 4 is 16 plus 1 is 17. And -1, -4 is -5. So these are the numbers I have to put. F of 4 is 17. And g of -1 is -5. And then I have to simplify this. So how you simplify it? We're going to do multiply first. 3 times 17. What is that? It's 51, right? Negative times negative, it's plus 10. So my final answer is 61. So that's how you do those expressions, okay? And then you have few more here to go. We have like the same idea. We have like 2 more. Or 1 more like that. And then these, the last 2, 9 and 10 are a little different. You have to plug it in. H is there, okay? It's not just number. So number 8 is the last one we have with plug it in only number. So here what you have to do, we have to find what is f of 4, then g of 3. So I need to put f of 4 minus g of 3 over f of 2. So let's find all these 3 numbers. So first, what is f of 4? F of 4 is going to follow the function f. So it's going to be x squared plus 1. And you're going to plug it in 4, so that's 17. So the first number here is 17. Then I need to find f of 2. So it's going to be the same. 2 squared plus 1 is 5. And 5 is down here. And then I have to do g of 3. What is g of 3? Was x minus 4 is g of 3? G. So it's going to be -1. So this is -1. So everybody see what I'm doing? You follow the function f, plug it in 4 and 2. You follow the function g, plug it in 3. You get these 3 numbers and then plug it into the expression given. And then you're going to simplify. So you have 17 minus minus is plus 1. So you get 17 plus 1 over 5, which give me 18 over 5. You can reduce this, so just leave it as improper fraction. Okay? And then we have 2 more to go, and the last 2 we're going to do the same idea. We're going to plug it in, and you're going to simplify. So these 2 we're going to use when you go to calculus for business, okay? I think everybody's next class, after this class, 1324, the next one is 3025, which is calculus, applied calculus for business. And when you go to that class, you're going to use, it's called different quotient. You're going to use different quotient to find derivative of function. So you're going to use that. And it's pretty much what we have right here, these 2 questions. So this is what you're doing. You're going to plug it in, whatever it says here in the function g. You're going to plug it in, whatever it says here, -1 in the function g. So you're using the same function g. And it's going to be over h. And then you're going to simplify it. Okay? So I have to do something minus something else. It's going to be a number over h. And then you're going to simplify from there. So let's find what is g of -1 plus h. So -1 plus h was function g is x minus 4, right? So that was -1 plus h minus 4 is going to be h minus 5, right? So that's what you're going to put here, h minus 5. Then I need to find what is g of negative 1, which is x minus 4. That's my function g. And I plug negative 1. So it's going to be negative 5. So I'm going to put negative 5 here. Okay, everybody so far so good? And then we're going to simplify the fraction. We have h minus 5 minus negative 5, everything over h. So what's happened here? We're going to take off the parentheses, so I have h minus 5. Negative and negative is going to be plus 5 over h. And then negative 5 and positive 5 cancel out. So you're going to get h over h is going to be 1. So the final answer is 1. So always when you simplify expressions like this, when you have h in the bottom, this h always going to cancel out. The h in the bottom always going to cancel out. Keep that in mind, okay? So if you make mistake somewhere and you don't cancel h, that means something's wrong, okay? So that's how you do this, and let's practice that one more time. So here we have f, so we're going to use the function f instead of g, and it's 3 plus h, so it's going to be something we're going to get minus a number, because I'm going to plug 3 for f in the f, everything over h. So this is what you have to simplify. So let's go ahead and do that. So we have f, which was x squared plus 1. So we have to find what is f of 3 plus h first. And the function f was x squared plus 1. So what is x? 3 plus h. Okay, so here we have to do a little FOIL. So this is a little bit, we have to do some steps, because 3 plus h squared means 3 plus h times 3 plus h and plus 1 in the end, right? So you have to FOIL. 3 times 3 is 9. 3 times h is what? 3h. And then 3 times h, another one. And h times h plus h squared. And then plus 1. Then you're going to combine those two, h and h, and you're going to combine 9 plus 1. So what you have, h squared plus 6h plus 10. So that's what you're going to have there. So we're going to have h squared, I'm going to copy that here, plus 6h plus 10. Okay? So this was f of 3 plus h. Then we're going to find the next one. What is f of 3? So f of 3 is x squared plus 1. That's the function f. And you're going to plug it in 3. So 3 squared is 9 plus 1 is 10. So it's going to be minus 10. Okay? So we simplify and plug it in everything in this fraction. And then from here, we're going to simplify the fraction. So I'm going to take off the parentheses first. So it's going to be h squared plus 6h plus 10. And then minus 10. So 10 cancel. And over h. Now, here we have h squared plus 6h over h. So I'm going to split this fraction. So I'm going to write it like h squared over h plus 6h over h. And you see this h in the bottom is going to cancel. I told you this h in the bottom always have to cancel out. See, h and h cancel. And one of the h's cancel here. So we have final answer is what? What is the final answer we get?
H plus 6.
Perfect. Good job. H plus 6. That's right. So remember, when you have expression like this, h in the bottom is going to cancel out. Okay? So this is what you have for section 2.1. Okay, so now we're going to continue with the domain of function. We're gonna talk about domain of function and piecewise function, which is section 2.2. Okay, so how you find domain of function? What is the domain? Remember, we talk about the function is correspondence between two sets of elements. The first one is called domain, and the second one is called range. And what you do, you teach element from the domain to get the second one is called the function, and the notation of the function is f of x. Okay, usually, I mean, most of the times, domain is represented with x and the range is represented with y. So now, domain is the first component, x value, the input value, the range is called output dependent, okay, and all that. So for most polynomial, rational, and radical function, and we're talking about only real numbers, okay? So if you have function with fraction, so these are only two restrictions you have. If you have function with fraction, there is a restriction. This is the restriction for square root, and this is the restriction for fraction. Okay, so let me explain how to find domain. So if your function have no square root and no fraction, domain is negative infinity, infinity, no restrictions. Okay, which means if you have, of course, if you have application problem where we talk about the range, we talk about the revenue. If x is from 1 to 20, that's going to be the domain. But in general, if you're just talking about functions in general, which is not connected to a real world application, then the domain is negative infinity, infinity. Okay, so if you have no fraction, no square root, this is the domain. If you have square root, how you find domain? Everything inside the square root, the expression inside the square root has to be always greater or equal to 0. It has to be positive number. And that's how you find the restrictions. That's the domain. Now, if you have fractions, something over something, the denominator is not 0. That's how you find the restrictions. And if the denominator is a square root, the expression inside has to be greater than 0, not equal 0. See, here you have greater or equal. If it's the square root is in the fraction, it's going to be greater only because the denominator for fraction is not 0. Okay, so let me do some examples. So A, the first example. So I have to go over this. Okay, so let's go over those questions. So why you have all these restrictions on the domain? Because when you have square root, everything inside of the square root has to be positive, because when you take square root of negative number, it's going to give you imaginary number. And in the functions, we're working only with real numbers. Okay, the restriction for fraction comes from fraction means division. So when you divide by 0, that's why the denominator is not 0, because when you divide by 0, it's undefined. Anything number divided by 0, it's undefined. You cannot do division by 0. So that's why you have all these restrictions on the domain. So now let's go ahead and do some examples. So the first one, A, we need to find the domain of function. And it says interval notation. That's exactly how I'm putting it with parentheses, negative infinity, infinity. No fraction, no square root, that's your domain, nothing else. You don't do anything else here. Okay, so that was the first one, negative infinity, infinity. Now the second one, B, we have to find the domain of this function. This function is a fraction, right? So if you have fraction, the denominator is not 0. That's how you're going to get the domain. So what is the denominator? X minus 3, not 0. What is x? You can add 3 in both sides. You just solve it. X is not 3. That's your domain. So if they want the interval notation, it's going to be x is not 3. means from negative infinity to 3, everything before 3, union 3 to infinity, everything after 3. So this is the interval notation. And there's another way of writing the domain with set builder notation. It's going to look like this. All the x's where x is not 3. So these are just two different ways to write the domain. So the first one is set builder, and the second one is interval notation. So that's how you write the domain, okay? And then the next one is C, where you have to find the domain of square root. So everything inside has to be greater or equal to 0. So we have to solve 3x minus 8 greater or equal 0. We're going to add 8 in both sides. And you're going to get 3x greater or equal 8. And then you're going to divide both sides by 3. And it's going to be x is greater or equal to 8 over 3. Now, x is greater than or equal to this number means the interval notation is going to be from 8 over 3 to infinity. Now, because you have these equals here, you're going to put bracket at 8 over 3. So this is the domain for the function. That's how you write the domain. Now, I'm just going to put a little note here. If you divide by negative here, see you divide by 3, right? If you divide by negative, you're going to flip this sign. Okay? That's the rule how to find the domain. Okay? So now, let's go ahead and continue with the next one. D. We have the function f of x is this fraction. So when it's a fraction, you have to solve the bottom not equal 0. So here you're going to have two solutions. We're going to solve this quadratic. We have to factor it. So what times what is negative 6? 2 times 3 and 1 times 6, correct? Now it's a negative, which means one of those is negative. And the sum is positive 1, so it's going to be, the bigger it's positive, so it's like this. Negative 1 and 6. Negative 2 times 3 is negative 6 when you multiply, and it's positive 1 when you add. So the numbers I'm going to use to factor this equation and solve, it's negative 2 and positive 3. So we factor the denominator like x minus 2 and x plus 3 not equal 0. This is not equal 0. So pretty much you're solving the way you solve equal 0, but you just cross the equal, not equal. So you solve x minus 2 not equal 0. And also you solve x plus 3 not equal 0. So you're going to add 2 in both sides for the first one. And the first restriction is going to be x is not equal to. And the other one, you're going to subtract 3 in both sides. And you're going to get x is not equal negative 3. So these are the two restrictions. Now, how you write that in interval notation? I'm going to put it in the number line so you can see negative 3 and 2 right here. So the domain is going to be everything before negative 3, between negative 3 and 2, and everything after 2. So here you're going to have 3 intervals for the domain. So the domain is going to be negative infinity, negative 3. Union means also negative 3 to 2. Union means also another interval from 2 to infinity. So this is going to be the domain for my function given. We have two restrictions on the domain. Okay? Any questions so far? No?
No, ma'am.
Okay. Then I'm going to go over number E. So because you have square root in the denominator, see what it says here. We're going to use this symbol, greater than only. So I'm going to solve the bottom greater than 0. And that's going to give me my restriction. So how you solve that? You're going to add 8 in both sides. and you're going to get x is greater than 8. So that's the restrictions. X have to be bigger than 8. And the domain is going to look like this, 8, comma, infinity. Now, 8 have to be with parentheses because we're not including 8. The domain starts from 8.00 after 8 to infinity, 001, right? So that's the domain for E. And then we have one more here, number F. We have to find the domain. So here we have two things. We have fraction and also we have the square root, but the square root is in the top. So if the square root is in the top of the fraction, we're going to do the same. We're going to be greater or equal 0 in the top. And also the denominator not equal 0. So these are two different expressions we have to solve. So I have to solve x plus 2 greater or equal 0. And also you have to combine it with x minus 6 not equal 0. So the first one you're going to solve when you subtract 2. So that gives me x is greater or equal negative 2. That's first restriction we have. And then the second one you're going to add 6. And you're going to get x is not equal 6. So from here, we're going to put this together. And the easiest way to do that is put it in the number line. So on the number line, I have negative 2 and I have 6. So the first restriction, x is greater or equal to negative 2, is going to be from negative 2 to infinity, right? Everything greater than negative 2. And the other restriction is x is not 6. So the second one is going to be not 6 means before 6 and after 6. So everything here. So where the two solutions intercept. So my final solution is going to be from here to here and from here to here, right? So my final answer for the domain is going to look like this. Bracket, negative 2, 6 with parentheses, union 6 to infinity. Okay? So that's how you find domain of functions. Any questions? And then you have a few more here you can try. Now I'm going to go to the next one, which is the different quotient and the piecewise functions you have down here. So the different quotient is pretty much the one we just did. Where I told you have to reduce, you have to, when you plug it in and simplify, this h in the bottom is going to cancel out. So how you do that? First, I have to do f of x plus h minus I need to copy f of x and over h. So this is the f of x. So what is f of x plus h? I'm going to do it step by step. F of x plus h is what? Replace x with x plus h. So it's going to be 6 x plus h minus 2. And you're going to simplify this. So it's going to be 6x plus 6h minus 2. So we're going to get this answer is the first one. Minus, we're going to copy the second one. So let's do that. So the first step is plug it in x plus h. The second step is we're going to do f of x plus h minus f of x. So I'm going to copy the previous answer from step 1. Minus the original function, which is 6x minus 2. So I'm going to take off the parentheses. So we're going to get 6x plus 6h minus 2 minus 6x plus 2. When you distribute the negative, 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 it's plus 2. Now, in these steps, you have to remember everything in these parentheses is going to cancel. See, 6x and 6x cancel, 2 and 2 cancel. So always this in parentheses is going to cancel out. So you're going to get 6h. So this is the answer for step 2. Then the next step 3 is going to be just plugging everything into the fraction. So it's going to be f of x plus h minus f of x, everything over h. So the top of the fraction is step 2, so it's going to be just 6h over h. And I told you that h and h are always going to cancel. So my final answer is 6. Okay? So that's how you do the different quotient. And the different quotient is the one you're going to use when you go to calculus for business class, next class, 1325. Okay? And then you have another example here. Let's do this again. We have, so here you have quadratic function. We have square, x squared. So when you have square, when you plug it in x plus h for the first step, you're going to get x plus h squared, which is multiplying x plus h, and that will give you, following this is the formula, a plus b squared is going to give you x squared plus 2xh plus h squared. If you want to use this as a formula, what is x plus h squared is this one, and you can just copy that. So let's go ahead and do the example for this function, and you're going to do the first step, which is f of x plus h, and that will be 3. I'm going to put x plus h square. Sorry, I want to erase this. Minus 5x plus h plus 8. And then x plus h squared is this one. So it's going to be 3x squared plus 2xh plus h squared. And I'm going to distribute the 5 minus 5x minus 5h plus 8. And then I have to distribute the 3 also. So it's going to be 3x squared plus 6xh plus 3h squared minus 5x minus 5h plus 8. So all this is my answer for step 1. Then step 2, I have to do f of x plus h minus f of x. So how you do that? I'm going to copy this answer from step 1. And I'm going to subtract f of x. I'm going to subtract the original. Because of this minus, I'm going to just distribute the minus. It's going to change the sign. So it's going to be minus 3x squared. It's going to change negative to positive 5x. And it's going to change 8 to negative 8. And then from here, we're going to simplify. We're going to cancel 3x squared and negative 3x squared. 5x and 5x, 8 and 8. Remember I told you here before, the example before, everything in the function f has to cancel out. We cancel it out. And let's see what is left. We have left with 6xh plus 3h squared minus 5h. So this is the answer for step 2. And then the step 3 is going to be f of x plus h minus f of x, everything over h. And now this h should cancel out in the bottom. So we have the copy from answer from step 2, 6x plus h plus 3h squared minus 5h. And everything over h, I'm going to put each of those over h so I can reduce easier. And here we're going to cancel 1h, square cancel with h, and h. And all the h's in the bottom cancel. And my final answer is 6x plus 3h minus 5. Okay? So that's how you do the different quotient one more time. And then I'm going to go over the piecewise functions. So here we have piecewise function. What is that? So piecewise function is function which have different pieces for different x's. So the function g here is x plus 1 when x is between 0 and 2. And the same function f is 0.5x if x is greater or equal to 2. So what that means, for different x's, you have different functions. So in order to graph it, I need to graph from 0 to 2 and then after 2. So let's graph the first one. So the first one is a linear function, and it's a linear function you need 2 points. So the 2 points I'm going to use are 0 and 2. Now, x is equal 0. So this sign here tells me I'm including the 0. So 0, the point is going to be a point, and a 2 is not included. So that means this point I'm going to get is going to be open point, which means it's not going to be included in the graph. We're going to graph an open circle. Okay, because the graph is going to go close to that point, but it's not going to be included. Okay, and then you're going to plug it in. When x is 0, we're going to plug it in this function. So it's going to be 0 plus 1 is going to be 1. Y is going to be 1. And then when I replace x with 2, 2 plus 1 is going to be 3. So these are the 2 points I need to graph. So I'm graphing 0, 1. So let's put the x and y axis here. So I have, let's say this is my x-axis and this is my y-axis here. So I'm graphing 0, 1. X is 0, y is 1 is this point. And then I'm graphing 2 and 3 is this point. Okay, so now I have to be careful. At 0, 1, I'm just going to graph a point. And at 2 and 3, it's over here actually, it's going to be open circle. Why is open circle? Because we have less than 2. It's not less or equal. It's not included. And then I'm going to connect those 2 points with a straight line. So this is my one piece of the graph. Then after that, I'm going to go ahead and graph the second piecewise of the function. So I'm going to make a little table for the second function. Again, I'm going to have x and y. And now here I'm going to pick x should be 2 and another number after 2 because it says x is greater or equal to 2. So I'm going to pick 2 and let's say I can pick 3. Doesn't matter, something bigger than 2. And then I'm going to plug it in. Or actually, because it's 0.5, let's pick 4. I'm going to pick 2 and 4. Okay, so when I replace x with 2, what is y? 0.5 times 2 is 1. And then I'm going to replace it with 4. So 0.5 times 4 is going to be 2. So these are the 2 points I need to graph and connect them with straight line. But keep in mind, x is greater, so the graph is going to continue this way. So it's going to start at 2 and 1. It's here. It's going to be a point. The next point is 4 and 2. The next point is here. But the graph is not going to stop at 4 and 2. It's going to continue this way. Okay? So this is my graph. We have 2 pieces of the graph, 2 pieces of the 2 different lines. And the domain of this function is from 0 to infinity because the graph, there is no graph below 0. So they don't ask you, but if they ask you to find the domain of this function is going to be from 0, including 0, to infinity. Okay? So that's how you graph it. Any questions? And then the next one is the same way. We have to graph the first function from 0 to 2, and then it's gonna be like pointer 0, pointer 2, and greater than 2 is gonna start from 2, but it's gonna have open circle at 2. Okay, so you graph it the same way. Okay, so the class is almost over. I'm gonna let you go. Have a good day.